All right, let's try this together. You first start out by getting rid of what's attached to x. So plus 1 is removed. You move it to the other side, which will give you 8. And since 4 is multiplied, you divide both sides by 4 to remove the 4. It gives you e to the negative 2x equals to 2. But then, see, 2x, negative 2 is multiplied and it's raised over e. Since e is done after multiplication by negative 2, e has to be removed first. What removes e? Yeah, it's log base e. If you take log base e both sides, these cancel, right? But there's a different name for log base e. What is this thing called? Natural log, ln. You rewrite, there's a shorthand for log base e. People just write ln of 2. So you have negative 2x equals to ln of 2. And now you divide both sides by negative 2, which gives you ln of 2 divided by negative 2. Now, some people get confused and they think, oh, I can bring this inside the log. If you do that, that will be very bad, okay? So this is full credit. However, a better way to write down the answer would be to say, usually you bring the minus in front. So that's a better way to write down the answer. Or another one that I prefer is, rather than saying divided by 2, I like to say multiplied by 1/2. Yeah. For some reason, I prefer this better than this. But these are both simplified form of this one. It's usually not recommended to have a minus in the denominator, nor square roots. Those are not considered as a simplified form if you see a minus or square root in the denominator. Okay, so that's the answer. Now, if you do really want to bring this negative 1/2 somehow into the log, what can you do? You can bring this in as an exponent. So ln of 2 to the negative 1/2 would be another possible full credit. So all of these are full credit answers. However, this is, I think, not that simple. It doesn't look that simple to me. For me, this looks the simplest. So let's say this is the answer. Well, any one of these 4 would give you full credit, okay? Okay, so for this one, there are 2 ways to do this. How many of you use logs to solve this? Can you raise your hand? Okay, a few. How many of you not use any logs? And still, okay. Yeah, so there are 2 ways to solve this. Let me show you how to solve it using log first, and then I want to show you how to do it without the log. So you can take log of 3, and the reason for that is both 9 and 3 are powers of 3, so log 3 seems to be fitting, right? So that these cancel and you get x plus 1 on the right side. On the left side, x minus 2 can be pulled in front, and then you can write 9 as 3 squared. Okay. And then you can still write it again as 3 squared is 3 to the negative 2 power, right? You have to know that that can be written like that. So these cancel, and therefore you have negative 2. Because this is a multiplication, it's not this minus, it's this times negative 2. So negative 2 and x minus 2 are multiplied. Let's simplify a little bit. You get negative 2x plus 4 equals to x plus 1. And then if I add 2x both sides and subtract 1, you get 3 equals to 3x. So that x is equal to 1. Okay, so that's one way to solve it with the log. Let me show you the second solution. It's slightly shorter. So solution 2. The second way to do this is to first rewrite 1 over 9 as 3 to the negative 2 for the same reason as we did this. 1 over 9 is 1 over 3 squared, and it's 3 to the negative 2. And then you put x minus 2 up here, and then you have 3 to the x plus 1. Now, what's the exponential rule if you have an exponent here and there? They multiply, right? So you end up with 3 to the negative 2 times x minus 2 equals to 3 to the x plus 1. And then you can say, since the bases are the same, the exponents must be the same. Right? Or if you don't like that argument, you can just take log base 3 both sides. There'll be another way to cancel the 3's. Either way, you end up with negative 2 times x minus 2 equals to x plus 1. Then after this, it's exactly the same situation as here, right? So you solve this and you get the same answer as x equals to 1, okay? So the answer is x equals to 1. All right, so the question that I always get is, can you do this? Can you do that? No, that's illegal, okay? And the reason that this is illegal is you can think of the following, like, say, 6 minus 1 is 5. Isn't that right? Everyone agrees with that, right? Is it true that 2 to the 6 minus 2 to the 1 is 2 to the 5th? That's not true. This is 64 minus 2. That's 62, whereas 2 to the 5th part is 32. So they do not agree. If you could do that, this should still be true, but that's not. That's why this kind of calculation is illegal. You can't do that. Therefore, what that tells us is that if you have more than one log, it's hard to get rid of the log. Therefore, what it means is that if you have more than one log in an equation, you always should combine them into a single log. Unless you do that, you won't be able to solve such equations. You get what I'm saying? Okay. So in both of these questions, you see more than one log, you have to combine them. Okay. How do you combine when it's a subtraction? It becomes a single log with division. Yes, x minus 1 over x minus 4 equals to 5. Now, because you only have one log, you can raise both sides with 2. And that's fine. Like, if you have 6 minus 1 equals to 5, it's okay to say 2 to the 6 minus 1 is 2 to the 5th part. This is perfectly logical. Right? Yeah. So that's perfectly fine. Okay? And now you can cancel the log 2 with 2, which gives you x minus 1 over x minus 4 as 32. And then you multiply x minus 4 both sides to get x minus 1 equals to 32 times x minus 4. That gives you x minus 1 equals to 32x minus 128. Let's add 128 both sides. And then also subtract x both sides so that you get 127 equals to 31x. And then you get x equals to 127 over 31. Okay. Another thing that you have to look out for is sometimes your solution might cause a domain error in the logs. See, logs cannot have 0 or negative inside it. The domain of the log is only positive numbers. So if it happens that when you plug this into any one of these and it causes domain error, then this will be an illegal solution. So in that case, this question wouldn't have any solution at all. However, if you actually plug this in, this is greater than 1 definitely, so that's fine. This is a bit worrisome, so let's see if that's okay. 127 over 31 minus 4 is 127 over 31. What's 31 times 4? That's 124 over 31. And that gives you 3 over 31, which is still positive. And that means this is quite fine. Okay? This will not cause a domain error when you plug in 127 over 31. Okay. So therefore, that is indeed a solution, so that's the answer. No domain error.
We need to write down the test.
Nah, it's fine. Yeah. Just do some kind of a check, okay? All right, so again, same idea. You want to combine two logs into one before you do anything, because unless you have a single log, you can't cancel it out. What happens if you combine two logs with addition? You end up with a multiplication. So you raise both sides over 4. Right? And then 4 and log 4 cancels away, which gives you x squared minus 12x, I multiply this out, equals to 4 to the third power, which is 64. Okay, so ideally, you should move the 64 on the left side and find two numbers that multiply to negative 64 and add up to negative 12 and figure out what those two are. But the numbers are a little too big to handle. Another way is if you're allowed a calculator, you can use the quadratic formula to solve. But this is a rare case where actually solving by completing the square is easier. You don't have to use that. You can use any other methods that I just said. But let's just solve by completing the square, okay? All right, so since half of negative 12 is negative 6, what should you add both sides? Half of negative 12 is negative 6. What do you add both sides? 6 squared, 36. You add 36 both sides. And this gives you x minus 6 squared. 64 plus 36 is 100. Therefore, x minus 6 would be plus or minus square root of 100. What's square root of 100? 10. So that means x is 6 plus 10 or 6 minus 10, which is 16 or negative 4. Okay. Are they both valid solutions? Is 16 okay? Yeah, that's okay because 16 minus 12 is positive. So this one doesn't cause any domain error, but this one does, right? Negative 4 will cause a domain error. So this one won't be accepted because if you plug in negative 4 here, it becomes negative inside the log. That can't be. So the only answer is positive 16. So answer is x equals to 16. Okay, next question. What should we do first? Combine the ln. Always, if you see more than one log, combine it first before you do anything. So we have two logs combined into a single thing as multiplication. So you have 2x equal to 3. Okay, now you have to get rid of ln. What gets rid of ln? E. So you raise both sides over e, which will cancel the e and ln, giving you 2x equals to e to the third power, and then you divide both sides by 2. That's the answer. And this will not cause a domain error, so that's fine. Now this next question, this one can be solved by using the log base 3, but as we have seen in the previous example, that often if the numbers on the base are exactly some powers, then it's easier just to use the exponential rule. So let's do it by just exponential rules. 9 is 3 squared. And then 27 is 3 to the third power. You multiply by 2 to this because that's the exponential rule. These two numbers multiply, so you have 3 to 2x minus 2. Since 2 is multiplied to the whole thing, 2 gets to be multiplied to both x and negative 1. And if you have the same base and you're multiplying, what happens to the exponent? They add. So 2x plus x gives you 3x. And now that both have the same base 3, therefore, for these two to be equal, the exponents must be the same, which means 3x minus 2 has to be equal to 3. 3x is equal to 5. Divide by 3, and you're done. Okay, I kept saying if you have multiple logs, combine them, but this one, it's already a single log if you think about it, because if you think about this as a separate thing, it's log of something equals to 2. So here, you can just readily remove log base 2 by raising it over 2. So raise both sides over 2. And that's going to remove this outer log base 2. And if you do that, you get log base 2 of x equals to 2 squared, which is 4. What next?
You raise by 2 again.
Raise it by 2 again to remove the inner log of 2. So these cancel, and you end up with x equals to 2 to the 4th power, which is 16. This is not going to cause any domain error, so that's the answer. Okay, so for this question, you have to know the formula, which is a equals to p times 1 plus r over n to the nt. This won't be given to you, so you have to memorize it. The future value is 6,000. Principal, the original amount is 4,000. The interest rate is 5.6. That converted into rate. If you convert that to rate, it's 0.056, right? 5.6% means per. This is per cent, right? Per cent. So per means divide. Cent means 100. So that's 0.056. If you take 5.6 and divide by 100, that's what you're going to get. What's n? 12. Why is it 12? Because it's monthly. So n is 12, 12t. And we're trying to solve this for t. That's the idea. Divide both sides by 4,000. Well, actually, this will give you 1.5, and if you take 0.056 and divide it by 12, you get 0.004, and it's a bit puzzling how many decimals you would want, but you want to put some more accuracy if you want at least, so probably if you want accuracy to the tenths, then you should use at least 3 digits. And if you want 2 decimal places correct, then you should use up till here. So the more the merrier. We'll just use more. Okay. Now what do? We take ln both sides. So we take ln both sides. This will be 1.00466667, so 12t. Because then this 12t can jump over the log, right? So that you have ln of 1.5 equals to 12 times t times ln of 1.00466667. And because we're trying to solve for t, we have to isolate t, which means I have to get rid of the 12. I also have to get rid of the ln. These should both be divided to the other side, so that you need to say t is going to be ln of 1.5 divided by 12, and also divided by ln of 1.00466667. Now the tragedy is we had a similar question on the quiz, and so many people got up till here right, but then used the calculator wrongly. What was the problem? They forgot this parenthesis, okay? So that's going to be a very important thing. Don't forget those parentheses. Parenthesis seems to be the number one weakness in so many of your calculations. You lose several points just because of parentheses. I might even say if you knew how to use parentheses correctly, then that's a matter of passing or not passing. It's like every few points every exam that adds up. So it's like passing or not passing, which is not good. So please be aware of when to use the parentheses and why it is needed. Those are very important questions. Okay, so if I do that, I end up with 7.26. So about 7.3 years. Yeah. Okay. Now let's think about number 7. Most of your calculators won't have the luxury of choosing this base. You would only have ln and log. And simply put, the base change formula says you can always write this as log 767 over log 9. That's it. That's what the base change formula says. Okay? And that's for any number here. So let's say you have log base 3 of 8. How do you put this into a calculator? Log base 8, log base 3. Done. That's how you do it in the calculator. And if you don't trust that it's true, or suddenly you got doubts about whether this is correct or not, then try to apply what I'm saying to something that you already know. So for example, what is log base 2 of 8? What's this value? 3, right? Because 8 is 2 to the third power, right? So everyone here knows that this is 3. And my challenge is this. Type this into your calculator. Log base 8 divided by log base 2. See what you get. You'll get exactly 3, right? Yeah. So same idea. You do this. So let's do that. Log of 767 divided by log of 767 divided by log of 9, and that's 3.023. 3.0231. It says, I didn't write here, but in the actual practice sheet, it says to write 4 decimal places, so that's what you get, okay? All right, did anyone try? Did you get 3? You did get 3, right? So this really works. Yes?
Do you use ln instead of log?
You can also do the ln as you get this. Yeah, because the base change formula says you can have any base. So you can choose the base with 10, that's the easiest. You can choose the base with e, that's also true. So you can do any one of them. Okay, now here we have question 8. And this is a rather important question because so many of you are confused about this. So let me point out first that let's first point out that log base 3 of 9 is what? What is this? 2, right? Because 9 is 3 squared. 3 times 3 is 9. So they cancel, so it's 2. Okay? So see if this makes sense. This is going to be 2 and 2 and 2, so you have 2 plus 2 plus 2. And that's going to be 2 and 2, so 2 times 2. Add them together. That's 10. Is that right? What do you think? No. Why is it wrong? So that's illegal. Okay. Let me put this more convincingly so you know what I'm trying to say. Can I say this is log base 3 of 9 plus log base 3 of 9 plus log base 3 of 9? This part right here? Is that right? Is that okay? No. You shouldn't do that. That's not true. Okay? If you have addition, it doesn't become addition. You can't split log like that. What is indeed true is that this one right here, this one is log base 3 of 9 plus log base 3 of 9. Okay? Multiplication splits as plus. Pluses don't ever split. It doesn't. Okay? So don't do that. Okay? Instead, how should you calculate this one? You have to do this first. 9 plus 9 plus 9, what's that? 27. So this is going to be log base 3 of 27 plus log base 3 of 9, log base 3 of 9. Okay, what's log base 3 of 27? 27 is 3 to the third power, right? So it's going to cancel like this, right? And then, of course, 9 is 3 squared. So they cancel, they cancel. It's 3 plus 2 plus 2, which is 7. That's the answer. Number 9, if graph of f of x equals to a to the x passes the point 2, 1/8, what is f of x? Since f of x is almost given to us and the only unknown number is a, this question is basically asking us to find the value of a. Let's see what this means. The graph of this function means y equals to a to the x. This graph passes 2, 1/8. If that happens, what do we know? Yeah, if we know that if x is 2, y must be 1/8. That's what it means to pass through 2, 1/8. Isn't that right? Yeah. How do you know a given point is on the graph? If you plug it in, the equation holds. That means it's a point on the graph. Okay? Because if you think about it, how do we graph something if this was as a concrete value? We just make a table of values, right? We would plug in 0, 1, 2, and figure out the value of y. And when we make those tables, when x is 2, y must have been 1/8. That's another way to think about it, right? So we just say y should be 1/8 if x is 2. That means a is equal to plus minus square root of 1/8. But by convention, we never talk about the graph of a to the x if a is less than 1. Okay? Less than 0. Yeah. If it's okay to be less than 1. Actually, this one, see, the graph of y equals to a to the x is either like this or this. If a is bigger than 1, then this is the graph. If a is between 1 and 0, then it actually falls down because the more you multiply a, where a is less than 1, it shrinks down, right? If you multiply 0.9 to itself again and again and again, the values decrease, right? So that's why the graph looks like this if a is less than 1. But if you want at 2, you want 1/8, which is lower than 1, then the only way it could be true is like it's this case. So we know that the value of a must be less than 1. But it has to be positive. So we can't choose minus. By default, it has to be positive. And this is going to be 1 over square root of 8. Therefore, you can say that the function f of x is 1 over square root of 8 to the x power. Okay? And indeed, 1 over square root of 8 is less than 1. Do you agree? It is less than 1, right? So that's the answer. However, as I said, it's not a good thing to have a square root in the denominator. So anytime you have a square root in the denominator, you should rationalize the denominator. How do you do that? You multiply by the square root 8 top and bottom, right? So that you get square root of 8 over 8. Another thing that you have to do is that if you have a square number inside the square root, you have to pull it out. So 8 is 4 times 2, right? 4 comes out as what? 2, right? So that's going to be 2 times radical 2. And you should reduce this so that it's square root of 2 over 4. Both 2 and 8 are divisible by 2, so you divide top and bottom by 4. So that's a better value. A is this, but you should simplify to this. So the better answer is going to be square root of 2 over 4 to the x power. Okay. So when I grade, I will be giving full credit for this, but the better answer is this one. Okay. Okay, now let's look at number 10. $1,000 grew to $1,400. So again, we are going to use this formula. Make sure that you come to the exam with this memorized. Okay? I'm not going to tell you during the exam. Okay. So if $1,000 became $1,400 after some mysterious interest rate is applied semi-annually, 2 is n. Semi-annually means n is 2, and total of 4 years were spent. Okay. Now you have to solve this for r. That's the question. How do you find r? Okay, so let's just divide both sides by 1,000. So these cancel. 1,400 divided by 1,000 is 1.4 equals 1 plus r over 2. 2 times 4 is 8. Okay. Now, how do you get rid of this 8? Because I'm solving for r, right? And this has to be removed. How do you get rid of 8? Oh, well, you could do it that way by taking ln both sides and then move the 8 down and then somehow. I don't really like that. Okay. So here's a better way. Take 1/8 power both sides. Then what's 8 times 1/8? It's 1. They cancel out, right? So you just end up with, on the right side, just 1 plus r over 2. On the other hand, where's my calculator? It's not, no, not there. Okay, on the other hand, if you do 1.4 to the power of 1 divided by 8, so in the calculator I did this, 1.4 to the power of 1 divided by 8. Again, don't forget this parenthesis or else it's completely wrong. Okay, it's very important that you have this parenthesis around. And if I do that, I get the value of 1.04295, something like this. Okay. So if I subtract 1 both sides, you get 0.04295 equals to r over 2. This is really like 0.043. Right? And if you double both sides, you get 0.0886 as r. So r is like 8.6%. So the answer is interest rate is 8.6%. Okay. That's the answer. Okay, question 11. This question is about combining the logs into a single logarithmic expression, right? And we all know that minus gets combined as division, right? So we can say that this is same as ln of 2x divided by x plus 1. But then I still have a minus 1 outside the log. And now the question is, how do you make this minus 1, which is outside the log, go inside the log? Well, some naive people might think, oh, maybe I should just do this. Is that good? Is that the answer? Of course not, yeah. It's not that easy, okay? So instead, oh, I shouldn't have to erase this. Instead, in order to combine these into a single log, you first have to change this into something that has a log. So in other words, I want 1 to be ln of something. Who am I? What do you think? Okay, somebody said E. Why is that? Well, ln of E is log base E of E. And then E is what? E to the first power, right? So we all know that ln means log base E, right? And then E is E to the first power. Now, if you cancel log E and E, what do you get? 1, right? So ln of E is the correct answer for that. Now that they have the same ln, what can you do? You can rewrite it as division. So that's the answer. The answer that belongs in here is that. Once again, although you will be given full credit for this, it's always a good thing to know how to simplify further. Now, some of you might think, oh, I just need to pass, and you might not be interested in how to write down the better solution, but you really need to learn these things because it helps you to improve math, and it will eventually help you a lot if you learn these skills. Okay, so first what you want to do is you can say that division is same as multiplication by what? By the reciprocal. So instead of dividing by E, we can say multiplication by 1 over E. Right? And now how do two fractions multiply? Top to top, bottom to bottom. So you have 2x on the top, and the bottom is E times x plus 1. So this is actually the better solution. So this is full credit, but not so good. The better solution is 2x over E times x plus 1. Okay? All right, number 12. This seems to be very similar to another question that we solved. So you might be asking, like, why should I put two questions that are almost the same? But if you look closely, there is something interesting here. It's compounded continuously, right? That changes everything. If it's compounded continuously, the formula is not the A equals to P times 1 plus R over N to the NT. You use the other formula. What's that? The PERT, right? A equal to PERT. The shampoo brand formula, okay, PERT. And you have to now just plug in everything and this should be fine. Okay, so your 5,000 is your principal. 9,000 is the future value. And then R is 0.016. T is the unknown. T is the unknown time. Okay. Now you divide both sides by 5,000. So that the left side will become 1.8 equals to e to the 0.016t. Okay, what next? Log base e, which is ln. So ln of 1.8, ln of e to the 0.016t, and then e and ln cancels. Now you divide both sides by 0.016, and that gives you the t. T would be ln of 1.8 divided by 0.016. Okay, let's see what that is. Ln of 1.8 divided by 0.016. That gives you 36.7 years. This last question is just plug and chug with the formula A equals to P times 1 plus R over N to the NT. And you're really looking at the future value with P principal 4,000, 0.05 is your rate. What's N? 4 because it's quarterly. What's T? 23 years. Okay. So that's what you have to compute. So I'll just type the whole thing. 1 plus 0.05 divided by 4. It's the power of 4 times 23. That's 892. Okay, that gives you 12543.04. So $12,543.04 is what you get. That's all for today.